Dear students, today we are going to discuss about Pn junction. Okay, so far we have discussed what is mean by semiconductor, what are the types of the semiconductors, and then what is N-type semiconductors and P-type semiconductors, how it is formed, everything we have discussed. But now we are going to discuss about Pn junction. So from the name you can understand if P-type and N-type semiconductors are combined, it forms the junction and in the middle of this. Okay, so what is that? Why we have to study about that? Actually, if P-type and N-type semiconductors are not used separately for practical purpose, because the overall charge of P-type and N-type semiconductor is electrically neutral. Okay, electrically neutral. But when we combine this P and N with each other, so that it behaves in a different way, okay, and then producing this Pn junction. So that part only today we are going to discuss. So before getting to the topic, I would like to say the application of Pn junction so that you will get the interest towards the subject. Okay, the P and N junction, that is P-type semiconductor and then N-type semiconductors are combined together. In the middle, it produces the junction. It produces the junction. So this Pn junction is named it as diodes. Okay, what is meant by diode? Diode is nothing but Pn junction, that is P-type semiconductor and N-type semiconductors are combined together so that it produces the junction in the middle, that is named it as diode. Okay, so this diode is the fundamental building block, or Pn junction is a fundamental building block. Okay, that is the basic building block of many other semiconductor electronic devices such as transistors, solar cells, LED, laser diode, and integrated circuits. Okay, this diode, this Pn junction is the basic fundamental building block for this kind of semiconductor electronic devices. What is meant by transistor? Now you see the diode. So diode means one junction is there. If transistor means two junctions will be there. That is P, N, P. So here one junction is there and here another junction. Okay, like another one also there. That is NPN. NPN. If two junctions are there, then it is called, that device is called a transistor. Okay, and then solar cell. Solar cell means sunlight. It will be converted into electrical energy. So LED. What is LED? Light emitting diode. Diode is nothing but Pn junction. The Pn junction is going to produce the light. Okay, same thing here also, laser diode. The diode will produce the laser light. Laser light is having some special properties than the ordinary light. And then integrated circuit. So this Pn junction is the building block for all the semiconductor devices. Okay, and these devices are the fundamental blocks, or the building blocks for electronic devices such as computers, control systems, and then ATM machine, that is automated teller machine, where we will get the money, and then mobile phones, amplifiers, etc. Okay, so now you get the idea. Okay, this Pn junction, where it is related. Okay, it is related to the computers, control system, ATM machine, mobile phones, amplifiers, etc. And various applications of diodes include power supplies, TV, radios, and so on, right? Okay, so the diodes are the simplest form of all the semiconducting devices. That is the basic thing. It's the simplest form of all the semiconductor devices. Okay, so before the invention of this diode, mainly before the invention of this diode, previously they used vacuum tubes. Actually, which these tubes are large in size. Okay, the size will be very big, and then it takes more power. If you want to operate this, we need more power, and it is costly. Okay, and it produces noise also. It produces the noise. Okay, these are the drawbacks of the vacuum tubes. Okay, before the invention of diode, they used vacuum tubes, but this vacuum tube is having this many drawbacks. But after that only, this problem was solved by the invention of diode. Okay, which are small in size. Okay, its size is very small, and then low cost. Okay, and it consumes very less power. It consumes very less power. So that is the importance of the diode. So now you have idea where the PN junction, that is diode, is used, and what that means, what is the advantages of this PN junction. So let us get into the video to understand how this PN junction is formed. Okay, so now we are going to discuss about formation of PN junction. Formation of PN junction. Formation of PN junction. So I am going to start from P-type and N-type semiconductor. Just to recall the points which is related to P-type and N-type semiconductor. So here P-type and here N-type semiconductors. Okay, so how these P-type semiconductors are formed? When trivalent impurity is added with semiconductor which forms P-type, it results P-type semiconductor, right? What are the examples of trivalent impurities? Boron, aluminum, gallium, indium. Okay, and then semiconductor means germanium or silicon. So it will produce the P-type semiconductor, first thing. And next, this that means here in P-type semiconductors, holes are the majority charge carriers. Holes are the majority charge carrier, right? And then electrons are the minority charge carriers. Electrons are the minority charge carriers, right? And then this trivalent impurity is also known as acceptor impurity or atom. Acceptor atom are impurities. Acceptor impurities. Why? Because this acceptor impurity means, what is the meaning? This trivalent impurity is ready to accept the electrons. Okay, it has holes, so it has the vacant side to occupy the electron. That's what it is named as acceptor atom, right? Now when we come to N-type, how the N-type semiconductors are formed? When pentavalent impurity is added with semiconductor which forms N-type semiconductor, right? Which forms N-type semiconductor. So now pentavalent impurities are phosphorus, arsenic, antimony, bismuth, etc. So when these elements are added with germanium or silicon, it produces N-type semiconductor, right? And then in this case of semiconductors, electrons are the majority charge carriers. Electrons are the majority charge carriers. Okay, and then holes are the minority charge carriers. Holes are the minority charge carriers. Okay, and then this pentavalent impurity is known as donor atom. Donor atom or donor impurities. Donor impurities. Why it is named like this? Why? Because this pentavalent impurity is ready to donate the electron. It is having excess electrons, so it is ready to donate the electrons. That's what it is named as donor atom. So now we have the clear idea about P-type and N-type. So the next step, I would like to draw the diagram what we discussed now. Okay, so when we see this P-type semiconductor diagram, this is P-type. So what we discussed, P-type is the P-type which consists of acceptor atom. Acceptor atom means which is ready to accept electrons. So now acceptor atom. The acceptor atoms are represented by the circle inside the negative sign. What is the meaning of negative sign? It is ready to accept the electrons. That means deficient of electrons are there. That's what this p-type consists of, acceptor atoms. Acceptor atoms which is ready to accept the electrons. Okay. That's what the symbol I mentioned, right? Okay. And then in p-type, holes are the majority charge carriers. So holes, actually holes which is represented by plus symbol, right? So plus represents holes. Why holes? Holes are the majority charge carriers. So here all the acceptor atoms are having holes. Holes are the positively charged. That's what I mentioned, the plus symbol to mention holes, right? And then in case of this p-type, electrons are the minority charge carriers. Electrons are the minority charge carriers. So electrons, minority charge carriers. So now you can understand the diagram of p-type. So p-type consists of acceptor atoms I mentioned, and then holes are the majority charge carriers and the electrons are the minority charge carriers. So now you can understand the diagram of p-type semiconductor. So same thing we are going to discuss for n-type also. So n-type consists of donor atoms. N-type consists of donor atoms. Now you see this. So donor atom is represented by plus symbol. Why? Because the atoms which are having excess electrons, ready to donate the electrons. That's what plus symbol I mentioned. So here this n-type consists of donor atoms. Donor atoms. And in case of n-type, the majority charge carriers are electrons. Electrons are negatively charged, so that this symbol. So it consists of electrons. This donor atom is having more electrons. So electrons are negatively charged. That's what I mentioned, the negative sign to represent electrons. So electrons are the majority charge carriers in n-type, right? And the next one is holes. Actually in n-type, holes are the minority charge carriers. Less number of holes will be present. So the plus symbol represents the positive charge of the holes. It is the minority charge carrier. So now everything we have explained in the diagram. So by seeing the diagram you can understand which type of semiconductor it is. So the negative sign with the circle represents acceptor atom, and a plus symbol represents holes, and a negative symbol represents electrons. So in p-type, holes are majority, electrons are minority. In n-type, donor atoms will be there. That means it is ready to donate the electrons. Why? Because it is having excess of electrons. That's what I mentioned, plus symbol here with the circle. And then electrons are the majority charge carriers, which is represented by negative sign, and the plus sign represents the holes, which are minority charge carriers. I hope you understand this diagram. Okay, now we have the clarity about what is p-type and what is n-type. The next step is Pn junction. Once the p and n-type is combined together, so what will happen? That is formation of Pn junction. Formation of Pn junction. So previously we have discussed separate p material and p-type material and the n-type material. So we will think that two different materials are combined together to form the junction. It is not like that. Actually we have three different methods of forming the Pn junction. That is grown junction method, and diffused junction method, and the third one is fused junction method. So these are the methods to form Pn junction. But now I am not going to explain these things. Okay, this is not our main thing. So here simply I will explain how the Pn junction is formed. Actually, instead of considering for p-type material, means what is that? When trivalent impurity, that is boron, should be added with the silicon or germanium, so that it forms p-type. Okay, and then here again we will take one silicon and it will be added with the phosphorus, then it forms the N type. Like that only we have discussed till now. But instead of taking the two materials, what we are going to do is take one single crystal of silicon material, single crystal of silicon material. With this silicon, at one part, at the one end of the silicon, they will keep the trivalent impurity. Okay, they will keep some small amount of trivalent impurity like boron. Okay, and they will apply the heat. So what will happen due to this heat treatment, the boron slightly go inside the silicon material. So what will happen now, when the boron moves inside the silicon, so that it produces the p type here. Okay, and then the same thing they will do for phosphorus also. So they will take the phosphorus and then they will give the heat treatment now. So the phosphorus will go, that means get into the silicon material, so it produce N-type semiconductor. Okay, so in this way they will form the Pn junction. So where the P and N are combined together, so this area is called Pn junction. This area is called Pn junction. So once these two are combined together, what will happen inside? Okay, what kind of reactions will take place inside? That is what we are going to concentrate now. Okay, so that I can give in steps. Okay, so what are the steps we are going to discuss here? So formation of Pn junction. So what are the steps we are going to discuss? Let us see one by one. The first part is diffusion. What is the first part? Diffusion. And the second one is formation of ions. Formation of ions. Okay. And the third step is potential barrier. Potential barrier. And the next step is depletion region. Depletion region. And then width of depletion region. Width of depletion region. So in this order we are going to discuss once the P and N are combined together. Okay, so let us see one by one. Diffusion, formation of ions, potential barrier formation, and then depletion region, width of the depletion region. So to explain this, I am going to combine this Pn junction. Already we have seen the diagram for P type and N type separately, but now I am going to draw the diagram combinedly. Okay, so one side P type material will be there, the opposite side N type material will be there, right? This is P type and this is N type. So the diagram will be same. So in P type what will be there? Acceptor atoms will be there. Okay, acceptor atoms. Acceptor atoms, and in P type holes are the majority charge carriers. So holes will be represented by plus sign. So now plus sign, right? And then in this case negative, that means minority charge carriers will be represented by negative sign, right? Okay, the same thing we have to discuss for N type also. So N type donor atoms, which is represented by the plus symbol inside the circle. Okay, so this is donor atoms. Right, and then here electrons are the majority charge carriers. So electrons are represented by negative symbol, minus symbol. So here electrons are there. Electrons are the negative majority charge carriers here. Okay, and then here also some few holes will be present as a minority charge carrier, like this, right? So now the same diagram only, but I combined both P and N junction. So now this part where these two are meeting together, where they are having the physical contact with each other, that part is called Pn junction. Pn junction. Okay, so as soon as these two are combined, what happens next? What happens next? Listen, the first step is diffusion. What is meant by diffusion? So the movement of charge carriers from higher concentration to lower concentration. From higher concentration to lower concentration, this is called a diffusion. So now you see here in P type, more number of holes are there. More number of holes are present in this P type. That is, holes are in higher concentration in P type. When the same thing when we compare in N type, very less number of holes are present. So here lower concentration of holes. Lower concentration of holes. So one side higher concentration of holes and another side lower concentration of holes. So due to this reason, the diffusion takes place. So the holes will move from higher concentration to the lower concentration. So this is represented by hole diffusion. Hole diffusion. So here the holes will move from P type to N type. So I can represent like this, P type to N type, right? So same thing in N type also. See this N type, here electrons are more, okay? So here higher electron concentration. Electrons are more here, and when we come to the P type, here lower concentration is there. Electrons are having lower concentration. So what will happen? The electrons will start move from N type to P type. So the electron diffusion takes place in this direction. Electron diffusion will take place in this direction. So as soon as the P and N are combined together, the first step is diffusion. Okay, so the holes will move from P to N and the electrons will move from N to P. Okay, so how long it continues? What will happen next? The next step is formation of ions. What is this formation of ions? Now you see this electron will come here. Okay, this electron will come here. Already these atoms are ready to accept the electrons. That is the name, acceptor atoms. So once the electrons reaches the acceptor atom near the junction, this acceptor atom, that means it accepts the electron and then it become ions. So this we have idea, that is acceptor atom. Okay, when it combined with the electron, when it takes the electron, then it become acceptor ion. Acceptor ion. So now what is that acceptor ion? Ion means without holes. Already electrons are combined. So without holes. Actually acceptor atom means we have to draw this with hole. Acceptor atom means this negative symbol with holes, but acceptor ion means only the negative symbol. Why? Because the electron is taken by the acceptor atom, so it becomes the acceptor ion. So all electrons will come like this. Okay, the holes will go like this. So by this time the electrons are accepted by the atom, so that here it produces negative charge. Acceptor ion is having negative charge. Negative charge. Okay, so negative charge means what we have to do? So near this junction, this acceptor ion so acceptor atom becomes acceptor ions. Acceptor ions. Okay, now you see this is acceptor atom, but these two are acceptor ions. The same thing will happen to the N type also. What is that? Here the donor atom which donates electrons. Okay, which donates electron. Here I used a plus symbol to add the electron. Here I used the negative symbol to remove the electron. So what will happen now? Donor ions will be created. So it gives the electron, so that it produces positive charge. It produces the positive charge near the junction. So what will happen here? This is the donor atom, which is represented by positive sign with the electrons. Now the electrons are removed. Okay, so that it will become only the positive ion. Positive ion. So now I'll just rub that negative sign. Why? Because this is not the atom. This is the ion. By donating this electrons, it becomes the ion. Now you see one side, near P side, Near P side, negative ions are formed. Which ions are formed? Negative charge. Okay, this is the negative charge. And near N type, positive charge is produced. Positive charge is produced. One side negative charge, that is negative ion, and another side positive ion is produced. That's what I mentioned. Formation of ions. Formation of ions. Positive ion as well as negative ion. Both are created here. Negative ions. Okay. So now what will happen if the ions are produced? Now see, this is negative charge. Okay, this side negative charge, and if the electrons further tries to come like this negative charge will repel the electron. Same thing in N side also. Here positive charge is there. Further some holes are trying to cross the junction. That time it repels. Why? Because this is positive charge and the hole is also having positive charge. So both will repel. So this formation of ions will prevent the further movement of charge carriers, further movement of electrons and holes. Okay, so that is the importance of the formation of ions. Once the ions are formed, then it prevents, okay, it does not allow the movement of charge carriers across the junction. So here positive charge means some potential. So now you see here positive potential is there, here negative potential is there. So that it build one potential difference here. It build the potential difference. This is the negative potential and this is the positive potential this side. So can you able to understand this part? So in near the junction, it produces one potential difference. One side negative and another side positive. So this total potential difference is there, no? The total potential difference between these two sides is called potential barrier. That is potential barrier. What is mean by barrier? Barrier means some obstacle, okay, like a wall. It prevents the further movement of charge carriers. This area, this region totally prevents the movement of charge carriers. So this area behaves like a wall, okay, behaves like a obstacle by using the potential energy. That's what it is called, potential barrier. That is called potential barrier. This potential barrier is also known as barrier voltage, or barrier potential, like that. Some other names also given to that. Okay, so this is potential barrier. For example, this potential barrier depends upon the that means material which is used, and the amount of doping, how much we are doping to get a P type and N type. So this potential barrier depends upon amount of doping, and then junction temperature, the temperature of the junction, and the main one is type of materials, type of materials. So for example, if you take silicon material, its potential barrier, that is barrier potential, will be VB is equal to 0.7 volt. 0.7 volts. Okay, if you consider germanium, okay, its potential barrier is equal to 0.3 volts. So depends upon the material, the potential barrier is varying. That we have to understand clearly. So now, till now, we have discussed the three steps. So as soon as the P and N are combined, first diffusion takes place. After diffusion, formation of ions near the junction takes place. So due to the formation of ions, one potential barrier is set up near the Pn junction. Okay, this potential barrier depends upon these things. Okay, that is amount of doping and junction temperature and type of materials. So for silicon, this potential barrier is 0.7 volts, and for germanium it is 0.3 volts. Okay, this part is over. Next we are coming to depletion region. First we must know what is mean by depletion. Okay, so depletion is nothing but, okay, depletion is nothing but empty or about to complete. Okay, for example, reduction or decreasing something, okay, decreasing the quantity of something. So for example, if I am saying oil depletion, I will go to the next page and explain in detail. So depletion means reduction. Depletion means reduction. Okay, slowly it will reduce or decrease in quantity of something. Anything it may be, quantity of something. For example, if you consider oil depletion, that means oil depletion means oil from where they will take from any oil, that means from some region they will take the oil. Okay, so the oil depletion means the production of the oil from certain area or certain region is keep on reducing. At one point of time it becomes empty. It becomes zero. So this is called oil depletion. This I just explained only for understanding. Okay, so in semiconductor physics, especially if you are considering in semiconductor, how can we define this depletion? So depletion region, okay, that region, one small region I am going to explain. The depletion region refers to a region where the flow of charge carriers, are decreased. Listen carefully. The flow of charge carriers decreased over a given time. Okay, and finally it results in empty. So here instead of oil we are going to talk about charge carriers. That too, flow of charge carriers, movement of charge carriers, flow of charge carriers. Here charge carriers are nothing but electrons and holes. Okay, so now again we will go to the diagram and discuss about the depletion region. So now you see here, this region is there now, this part, okay, that is where the ions are formed. This region is called depletion region. Why it is called depletion region? Now you see, first when these two are combined together, when p-type and n-type are combined together, first diffusion takes place so that the movement of the charge carriers is more enough. Okay, after that, once it formed this ions, positive and negative ion, and set up the potential barrier, slowly the movement of the charge carrier is reduced. At one point there is no movement of the charge carriers, that we observed clearly. Okay, first it is more, but slowly it reduced and finally it becomes zero. So this region is called depletion region. So what is the depletion region? Here what will happen? First, we can say in two ways, that is, in this case, in depletion region, empty of mobile charge carriers. What is mean by mobile? Mobile means moving. Okay, empty of mobile charge carriers, or otherwise, how can we say this is empty means opposite will be full of immobile. What is the meaning of immobile? There is no charge carriers moving. Okay, so immobile charge carriers, in both the way we can represent. That means the depletion region is full of, that means is empty of mobile charge carriers, refers the empty of mobile charge carriers, are full of immobile charge carriers. There is no charge carriers moving over there. So full of immobile charge carriers. In this way we can explain the depletion region. So this region, that means this region is called depletion region, and this depletion region is also represented by depletion zone. Or okay, space charge region, and then are space charge layer. So with these names we can represent this region. Okay, that means first the movement of the charge carriers will be slowly reduced. At one point it becomes empty. Okay, so that region is called depletion region, which has different names also, that is depletion zone or space charge region or space charge layer. Okay, so now you will have the idea about depletion region. So the next, what is that? Width of the depletion region. So that is one small point we are going to discuss. That is, here in that diagram I explained the width. That means width is nothing but the size of the depletion region. Okay, this is the size of the depletion region. So the size of the depletion region can be changed. Okay, it can be modified. How can be modified? The width of the depletion region depends upon the amount of impurities added. The amount of impurities added. So here to make P type we will add the trivalent, to make N type we will add the pentavalent impurities. So depends upon the amount of impurities, the size, the width of the depletion region changes. So what is that? For example, if you dope the material heavily, okay, that is more number of P type and N, that is the trivalent and the pentavalent impurities are added, which is termed as heavily doped. So when it is heavily doped, when the junction is heavily doped, then the depletion region decreases. Okay, decreases over a period of time, over a given period. That means instead of this much size, it becomes narrow. It becomes narrow depletion region. Okay, and the second one will be opposite, that is lightly doped. Very lightly, very less amount of impurities are added, then the depletion region increases. Okay, increases over a period of time. So when this size is increased, it becomes wide. So wider, narrow depletion region or wider depletion region depends upon the doping, depends upon the amount of impurities added. So this is what the depletion region width. Okay, so now you see, to form the PN junction, I explained the 5 steps. Okay, we have discussed one by one in detail. So just go through this. Okay, if you have any doubt, you can ask in the comment section. Okay, thank you everyone.